Hello everyone. Uh, if you are confused with how to implement the Boolean functions or combinational circuits using transmission gates, so here's the answer. In this video, we'll talk about how to design half adder using the transmission gates. So let's start. As usual, our first step is going to be to draw the truth table of the given circuit. In this case, we have the half adder, and we know for half adder we need two inputs and we will have two outputs. So let's draw the truth table. At the input side, we'll take the two inputs, namely A and B, and at the output side, as we know, we will have sum and carry, which is C out. Now basically, if you have two inputs, we'll get four combinations starting with 0 0, 0 1, 1 0, and this is going to be 1 1. Now coming to the point of sum and carry, when I add these terms, definitely for the first combination we'll get 0. 0 plus 1 we will have sum 1 carry 0. 1 plus 0 again sum 1 carry 0. And last 1 1 we will have sum 0 and carry 1. How it comes we have already explained while designing the half adder circuit. Now based on the truth table, our second step will be to draw the logic diagram with the help of transmission gate. So let's draw this. Here we'll simply write the logic diagram. You can write the name as per your convenience. So while drawing the logic diagram, the first thing that comes into mind is how many transmission gates are required. So for that case, we will have the answer. As we need two inputs, namely A and B, we will require two transmission gates. And we have results as sum and carry. So let's first implement this for the result called sum. So here we'll be drawing a set of transmission gates. This is our first transmission gate, and this one is second. Now coming to the point of control signal, so always check the LSB bit as the control signal, which is nothing but B. So here we'll be getting B, this will be B bar, again the same B bar, and this will be B. This is how we make arrangement of our transmission gate. This is transmission gate number T1 and this is T2. Now we'll short these two terminals, and this will be our first output as sum. Now the point arises, how can we connect A, 0, 1 or A bar also? So that comes from the logic of truth table. Here first we'll deal with when the control signal is 0. You can see when B is equal to 0, our result sum is 0 and here it is 1. Now as we are getting two different results, one as 0 and another as 1, it entirely depends upon A. So let's come across A. Now see, for the first combination A is 0, sum is 0. That means both are same. This combination A is 1, sum is 1. Again it is equal to A. That means when B is 0, that is nothing but the first transistor case, this will be turned on. When B is 0, this will be turned on, and if it is turned on, it should be connected with A. So sum is equal to A. Counterpart, when B is equal to 1, when B is equal to 1, we have these two combinations, this and this one. Now for this case, you can see when B is 1, our sum is 1, and for this combination sum is 0. So looking to the point, they are different. That means it should depend on A. Let's see what is A. Here A is 0, we are getting sum 1. Here A is 1, we are getting sum as 0. That means it is complementary. 0 is complement 1, 1 is complement 0. So second case, when B is 0, this transistor will turn on. How it turns on, we have already seen in case of the working principle of transmission gate. So I can connect this with A bar. So when T1 is turned on, A is equal to sum. When T2 is turned on, A bar is equal to sum. So this is how we have implemented sum. Now let us come across the carry. Again, we'll draw a set of two transmission gates. Here again same scenario, B bar, this is B bar and this is P. Let's short these two sockets. this is our cout. Now let's come across which input should be connected. Again the same term. First let's start with when b is 0, control signal b is 0. If b is equal to 0, if we come across the result, here carry is 0, here carry is 0, that means we are getting same result. So from that we can conclude when b is equal to 0, this particular transmission gate, let's suppose this is T3, it should be connected with ground, that is C. Next, when B is equal to 1, these two combinations, this and this. Now these two combinations, if you see our result, carry here is 0 and in this case carry is equal to 1. Now they are different, so if they are different we have to look after A. Let's come across A. Here A is 0, carry is 0. Here A is 1, carry is 1. So we can say A is equal to cout, A is equal to cout. So based on that, when B is equal to 1, T4 will turn on and it will be connected with logic A. So cout is equal to A when this is turned on, cout is equal to 0 when this is turned out, and this becomes our half adder implementation using transmission gate. So I hope you understood how to implement half adder. Now you can apply the same logic for full adder, half subtractor or full subtractor also. Thank you so much.